Planking. Instead of using science form-based assumptions about doing unidimensional and uni-unit things, I decided to do a little bit different version of it. Anything that can be measured with a single value can be anything you want it to be. It could be the diameter of a circle, and you could just call it the diameter. That's a single dimension. But I wanted to point out, like I did in a video that I've already done, that if you want to talk about unidimensions, we almost always think in science about a voltage level, a heat level, an energy charge level on something that has a single dimension, that charge. It has no dimension physically, but there are unidimensional physical objects. I'm going to bring up something pretty simple. For all practical purposes, something moving at the speed of light moves normally in a pretty straight line. On smaller and smaller scales, you could even say it's extremely straight or perfectly straight. On an extremely small scale, however, the vibration of a radio signal or electromagnetic signal, magnetic field, or in this case, all of it, is going to have some dimensional change, even if it's another dimension just magnetic or the charge itself. And that also applies to particles. There is some debate as to whether or not they cycle in some way that we're just not simply able to understand. I mean, you don't know. So let's talk about a unidimensional object that's good. Instead of a ray of light, let's talk about the pathway taken by an object in time-space that is, we will presume, empty. And the thing is, we don't even have to presume it's empty because of what example I'm going to bring up. Planck units, if you're not aware of it, are not the smallest units anything can be measured. Planck time is a lot longer than some other things that can be measured. The lower bound for how small something is not something understood. On Planck scales, you can have things smaller than that. The expansion of a black hole, given any amount of matter or energy, will change the diameter of the black hole, no matter how tiny. In that brief period of time it changes from one size to another is smaller than a Planck length. If you get a small enough amount of matter or energy to fall into it, it will change by a dimension that is smaller than a Planck length. Therefore, it cannot be the lower limit of tessellation or incrementation in time-space. When discussing time-space, I like describing it like a chain link fence simply because it makes it easier. As something passes through time-space, it's like running your finger over a chain link fence. Only because of the delicacy with which time-space works and its extreme durability, you're not just tapping the chain link fence. You're smacking it hard enough that it doesn't just warp with you. It warps in such a way that it forms a corkscrew around things because everything interacts on those scales in ways that are exotic looking. This does not mean that any quantum woo page that you look up is accurate. They're bullshit. But on those scales, given a small enough object, if you could observe from its standpoint, omnipotently and omnisciently, you would absolutely detect that it is going through time-space, not like a bulldozer, but like a hammer through cobwebs. But the cobwebs don't break. They just warp around it. Such is the nature of extremely small-scale, unidimensional objects. So we're going to do the pathway of an electron. Electrons are presumed to be non-dimensional. They have no dimension to them. They're a point particle. They have a sphere of influence, and that dynamic, the diameter of an electron, if you want to look it up, refers to its sphere of influence at the hard level, depending on how you're defining it, is not a zero number. But we're going to call it a zero number. And you can get an electron moving very close to the speed of light. And if there's an annihilation of subatomic particles from something to another, like quarks, you will often end up with them spontaneously generating from the grid of time-space running into those chain-link fence wires. You will end up with an electron forming. You might have an unstable version of some other form of subatomic matter, and it could be non-dimensional, have no dimension to it at all. It's just a charge. And it will move from here to here and obliterate itself within what we would conceive of an excruciatingly tiny distance. Let's presume this has happened within a Planck length, because that would make it unobservable. Mostly because that eliminates the need to talk about observing it and testing for it. There's no way to do so. Or is it? But anyway, at this distance, let's say it formed from here to here, And its sphere of influence was the size of my fingernail, which is very, very short over here, and it went from here. That's a fairly long distance. That's around the order of 10 to 20 to 1. And in this distance, as it moves, it forms a line segment in Planck time. Planck time is not the shortest form of time that you can measure, but it would form little dashes that we would perceive if we were looking at the universe like a roll of film, with each frame taking 1 Planck time of space, and this was 1 Planck unit. Let's presume that. And it would be a line segment this short, and it would be moving this way. If we did shorter chops of the universe, which there's no reason not to believe it, it would eventually become an individual particle size. At a certain point, or an uncertain point, the dimension of that dot would not change size. We would just see it holding still for hundreds and hundreds of frames if we made the frame rate faster, shorter than Planck time. But at some point, through the magic of treating the entire universe as an infinite string of snow globes, or large blocks of plastic you can see through, you would see a line segment, like a scratch. And at this scale, without it running into the tessellation, or whatever you want to call it, of the universe, this Planck length that you would come up with, I'm going to call it 1 Planck length, or 1 billionth, or 1 picoplanck length, would effectively form a straight line that doesn't deviate in any way around its axis, that would have a single dimension to it, and it would be essentially a subatomic particle moving through time-space. But for that little snapshot of reality, that would be, let's say, whatever it is, the shortest period of time that anything can exist in the universe, it could exist in that single frame as a single scratch on the glass pane of the universe. And it would be a unidimensional item only having length. Now let's push this dimension experiment further. Having whatever it is, this is the shortest period of time that you can actually experience or be able to have experienced by the universe that would leave a permanent ding on the clock of time going through. What if you had one that is truly the smallest version of this? This means that whatever would happen in those time spaces would take up a single frame of the universe's time scale, and they would have a distinctive length. Now remember, we're talking about particles that would be moving at ridiculously high speed, ludicrous speed, and be moving in such a way that it would leave, if the time scale was actually much longer than we think it is, a little line. And you could have an object that could form and annihilate in that period of time, or even shorter, that would just be a little line with nothing else about it recorded, left as a footprint in time. This would be a perfectly straight object, presumably, or at least as practically possible. It would occupy only really one dimension, its length. It could be plotted as 2 points between which there is a line drawn, but you could truly call it a unidimensional object. It only has length. Its width and height have no dimensions to it. There's no presumption that it has to. We could say that the sphere of influence is the size of this dot, but if we looked on it end on, it would simply disappear to us. It would only be evident if we could freeze time and then magnify ourselves or microscopify ourselves. That's a new word. We would see a line. Let's presume that existed. And let's assume that we then looked from its perspective out into the rest of the universe. It should be pointed out that if you escalated the size of a hydrogen atom up to the size of a football field, you would not be able to look at a Planck length. If you took a football field and made it the size of the known universe, 13 billion light years in each direction, it would become a football field where you could find atoms being fairly large, but a Planck length would be the size of a conventional atom in my fingertip compared to that scale change. Planck lengths are really, really tiny. But a hydrogen atom is 100 trillion Planck lengths, and a proton's diameter is merely 100 billion Planck lengths approximately. But they're not the lower limit. But our little freeze frame of time-space would have an interesting thing about it that should be important. Even if this happened within a highly dense diamond or inside the core of a compacted neutron star, it would still be at such an extreme scale that this object, that would be whatever is the absolute minimum size of the universe, beyond any idea we can have even for quantum mechanics level, would be a straight line that would be lonely in every direction, that would be on any scale you and I could understand, even to see the furthest stars with the best telescope. That level of distance, it would be empty space to this thing. Within the diameter, of a proton is 100 billion Planck lengths, and this is probably smaller. It would not be able to see, perceive, be affected by anything. Its short existence would be the shortest living time period for anything. Not enough time to form a thought or have a reaction. And yet at this scale, if you could magnify it further, it would probably show that it isn't truly unidimensional in its path. It would show some peculiarity we do not know about. No matter how small the scale or how practical a straight line, can you have a unidimensional object? On one explanation, it has to exist. On another, it would be impossible to detect. Thank you for watching. Have a good day, and good luck with all of this.